Hello students, welcome to our Chapter 3 lesson on complex numbers. A complex number is a number of the form a plus b times I, where a and b are real numbers, and I is equal to the square root of -1. So kani si I, mao ni siya ang ato ang gitawag og imaginary number, which is equal to the square root of -1. Kung ato ni siyang i-calculate sa calculator, ang mugawa sa square root of -1 is math error. So, ang kaning I is an imaginary number. Since dili man ta pwede na ay negative sa sulod sa ato ang square root. So, si I ang nag-represent as imaginary number. Sa atong complex number, mao ni siya ang form sa ato ang complex number. A plus B times I. Si A o B elements sa real number, pero si I is the imaginary number square root of -1. In a complex number, A plus B times I, A is called the real part and B the imaginary part. If B is equal to 0, A plus B times I is equal to A plus 0I. So, gisubstitute ang B og 0. If B is 0, so gisubstitute nato si 0. So, ang mahitabo, it is equal to A na lang. And A is a real number. And if A is 0 and B is not equal to 0, so A plus B times I is equal to, so kung 0 si A, substitute nato si 0, pero si B dili 0, so ang mahitabo, that is 0 plus B times I, which is equal to B times I or BI. That is pure imaginary. So, kung B times I na ang mahabilin, pure imaginary na siya. Thus, the set of the complex numbers are A plus B times I, such that A and B are elements of the real number system, and I is equal to the square root of -1. Includes the set of real numbers. So, ang atong complex numbers, ang subset, ang real numbers dito. So, the real numbers is equal to A plus 0I, which is equal to A, and A is the element of a real number. And the set of imaginary numbers, so we have the set of imaginary numbers, I is equal to 0 plus BI, which is equal to BI, where B is an element of the real number and B is not equal to 0 as subsets. So again, ang imaginary numbers o ang ato ang real numbers subset sa ato ang complex numbers. A complex numbers is in standard form if it is of the form A plus BI. So this is the standard form of a complex numbers. So like ato ang complex numbers with the real number system and imaginary numbers last time kani. So mao ni siya ang universal set nato, the complex numbers. So subsets sa complex numbers are the imaginary numbers and the real numbers. So mao na siya ang ato ang complex numbers. Now let's go back. We have here some examples. The number -1 plus 2I is a complex number. The real part is -1 and the imaginary part is 2. Okay? Ang ato ang real part is this, the -1, and the imaginary part is 2. Next, the number 11 minus 15I all over 3 is a complex number. The real part is 11 over 3 and the imaginary part is -5. So, ang real part nato kani 11 over 3. Then, the imaginary part is -15 over 3, which is -5. So, that is the imaginary part. Third, the real number 2 is a complex number. The real part is 2 and imaginary part is 0. So, ang real number nga 2, complex number day gihapon ni siya. Pero lang, ang iyang imaginary part is 0. So, that could be 2 plus 0i. Mao na nga 2 na lang ang nabilin. Last one, the number negative 4i is a complex number. The real part is 0 and the imaginary part is negative 4. So negative 4i is called here the pure imaginary number. So kani siya pure imaginary number. Ang atoang real part is 0. So 0 minus 4i na siya. Complex number na siya. So, ang 0 real part and the imaginary part is negative 4. And ang tawagan niya kay pure imaginary number. Next, two complex numbers a plus bi and c plus di are equal if and only if they have the same real part and the same imaginary part. In symbols, a plus b times I is equal to c plus d times I if and only if a is equal to c and b is equal to d. So let us have some examples. Find the values of x and y in each of the following equations. So given this equation, number 1, x plus y times I is equal to 3 minus 4 times I. So, kung equal ni sila, so ang mahitabo, ang atoang x is equal to 3. And then ang atong y is equal to negative 4. So, those are the values of x and y. Next example, 2 times I minus x is equal to 1 plus y times I. So, if we have this equation, wala pa rin naka-standard form, diba, sa atong complex number. So, kung ato ang i-transfer si 2i sa pika side sa equation, mahimo ni siyang negative 2i. So, from here, nabalhin siya sa pika side sa equation, mahimo siyang negative 2i. Kung ang ato apong plus y times I diri sa pika equation atong itabok diha para baka forma tag standard equation, ang kaning positive may mo siyang negative sa pikas. That is why ang left side sa equation negative x minus y times I is equal to ang right side put sa equation 1 minus ang atong gitabok nga 2 times I. So ato siyang factor out ang negative para makaporma tag standard form. So, kung ipagawas na to ang negative diri, mahitabo, mahimo ni silang positive. So, x plus y times I, which is equal to, pagawas po na to ang negative niya sign. So, ang mahitabo, mahimo na siyang negative 1 plus 2 times I. So, ang ato ang naman ta sa ato ang standard form. So, mahibawan na nato unsa si x, unsa si y. So, ang atong x di is negative 1 and ang ato ang y is positive 2. Operations and complex numbers. First, we have addition. A plus b times I quantity plus the quantity of c plus d times I is equal to a plus c quantity plus b plus d quantity times I. Subtraction. A plus bi quantity minus c plus di quantity is equal to a minus c quantity plus b minus d quantity times I. In multiplication, a plus b times I quantity multiplied to c plus d times I is equal to a times c minus b times d quantity plus b times c plus a times d quantity times I. The conjugate of a complex numbers a plus bi is the number a minus bi. So that is called the conjugate. Remark, a plus bi multiplied to a minus bi is equal to a squared plus b squared multiplied to b times a minus a times b multiplied to I is equal to a squared plus b squared that is greater than or equal to 0. Then we have division. A plus bi all over c plus di is equal to a plus bi all over c plus di multiplied to c minus di over c minus di. So note, we have here I to the power of n that is equal to positive or negative 1 if n is even. Then positive and negative I if n is odd. Another, we have negative 1 to the power of n. The result would be 1 if n is even and negative 1 if n is odd. So in particular, let us have some examples. I squared, so when we square the square root of negative 1, that is equal to negative 1. Then if we have I cubed, we can factor it out as I squared times I. Since we know that I squared is negative 1, so negative 1 times I is equal to negative I. Next, we have I to the power of 4. We can factor it as I squared times I squared or I squared squared. So I squared again is negative 1. So if we square a negative number, that becomes positive. So only 1 ni siya. So I to the power of 5. So we can factor it as I to the power of 4 times I. We know that I to the power of 4 is 1. So 1 times I is I. So I to the power of 100, that is I squared to the power of 50. So equal na siya kay 2 times 50 is 100. So we know already that I squared is negative 1. So negative 1 to the power of 50 is equal to 1. Diba? Kung even ang ato ang n, even man is 50. The answer is 1. Next, 1 to the power of 20, I to the power of 27, that is equal to I to the power of 26 times I. And I squared to the power of 13 is 26, diba? 2 times 13 is 26 times I. So again, I squared is negative 1. Pag negative 1 to the power of an odd number, that is equal to negative 1. So negative 1 times I is negative I. So based sa atong note, pag even ganita ang power ni I, naragyo na sa positive or negative 1. Pare ani. Even si 2, so negative 1. Si 4, 1. Si 100, 1. So, kung add po ang ato ang exponent, ang resulta positive or negative I. So, parehan ni. I to the power of 3, negative I to the power of 5, I to the power of 27, negative I. Samo na siya ato ang timan-an when we simplify a complex number. Square roots of negative numbers can be written as imaginary numbers. So, we have here examples. Square root of negative 4. So, kung i-calculator nimo na siya, dili na siya nimo ma-simplify. Since mag-math error man ta basta negative ang sulod sa atong square root. So, here's how to simplify it using imaginary numbers. So, square root of negative 4 is equal to square root of negative 1 times 4. So, ato ang ipuan factor out si 4 by negative 1 para mapagawas nato si square root of negative 1 which is your I. So, this can be square root of negative 1 times square root of 4. So, we know that square root of negative 1 is I and the square root of 4 is 2. So, I times 2 is equal to 2I. Next, we have here the square root of negative 3. So when we factor it out, that is square root of negative 1 times 3. Then, iisa-isa na to kada term. Okay ra na siya ibulag since multiplication man. Pag addition ag subtraction, di na siya pwede mapulag ang square root. So here, pwede ra gyud nato siya ma-factor as square root of negative 1 times square root of 3. So square root of negative 1 is I times square root of 3. So that is square root of 3 times I. Another, simplify each of the following and express its standard form. Number 1, quantity 3 minus 5 times I plus quantity negative 4 plus 7I. That is equal to, so saan na to pag-simplify? So based sa ato ang formula, last time ato ang gikuan, kani sila, the addition, subtraction, multiplication. Then we have the division. So atong gamiton ni sila to simplify this complex numbers. So baliktad 3 og ang negative 4 atong i-add. Diba? Based sa ato ang guide ganiha, i-add na to ang kaninga term o kaninga term. So that would be 3 plus negative 4. Then i-add na to ang sum pud aning duha. So ang negative 5 o 7. Then we multiply it by I. Gisunod ra to nato atong guide. So to simplify further, ato ning ikon na operation 3 plus negative 4, that is negative 1. Then negative 5 plus 7, that is positive 2 times I. Next, number 2, 1 over 3 minus I, that is equal to, so pag inani gani, we use ang ato ang guide gani ha. So 1 over 3 minus I times, ato ang to eliminate this 1, since minus ni ato ang i-multiply diri is plus. Sa numerator denominator na. So, ang atong result, 1 times 3 plus I is 3 plus I. All over, ang resulta ani, pag ato aning distribute o multiply, so 3 times 3 is 9, and then 3 times I, that is 3I, minus I times 3, that is 3I, so 3I minus 3I, that is 0. So, negative I times I, that is I squared. Negative I squared, which is equal to 1. So, 9 plus 1 is 10. So, ang ato ang answer na, final answer is 3 over 10 plus 1 over 10 times I. A complex number a plus bi can be interpreted geometrically in the plane as a directed line segment from the origin to the point whose rectangular coordinates are a and b. The modulus or absolute value of a complex number a plus bi is the distance between the point a, b and the origin. Ang origin nimo is 0, 0. Or the length of the directed line segment representing a plus bi. The modulus of a plus bi denoted by the absolute value of a plus bi, muna siya ang modulus, is defined by the absolute value of a plus bi is equal to the square root of a squared plus b squared. So examples, find the value of the following. So given tag the absolute value of negative 3 plus 2i, we just have to square root negative 3 squared plus 2 squared. So this negative 3 squared is 9 and 2 squared is 4. So we add that. That is square root of 13. Next, we have here given the absolute value of negative 3 minus 4i. Let us just square root. and square the negative 3, then add the square of the negative 4. So the result is negative 3 squared is 9 and negative 4 squared is 16. So if we square a negative number, diba, ma-positive ra gihapon. So morning 9 plus 16, which is square root of 25, that is equal to 5. And the last example, we have here the absolute value of 2 plus 0i. That is equal to the square root of 2 squared plus 0 squared. So 2 squared is 4 and 0 squared is 0. So that would be the square root of 4, which is equal to 2. That ends our chapter 3 complex numbers discussion.